Alright, this is a system of equations with three variables. Now, when you guys look at these in your books, sometimes they will align the variables like you see right here, okay? But it's not necessary that it be that way as long as you understand that they can be that way. And when that happens, really you just don't have any y's here, and in this case you wouldn't have any x's either. So whether you show those or not is up to you. But for the most part, when you see them in a book, they're going to look like this. So let's go ahead and use this system right here and solve it. So the first thing we're going to do is choose two of the equations, and then we're going to eliminate one of the variables, and then that will give us a new equation and two variables to work with. So knowing that, let's go ahead and choose the top two. So we'd have 3x minus 2y equals negative 1, and the second equation, 6x minus 2z equals 4. So in order to eliminate one of these variables, and it looks like the only one we really can eliminate there is the x's. So we need them to have the same coefficient of x, which would be 6. So in other words, this top equation, instead of being a 3x, we need it to be a 6x. And to do that, we would have to multiply the 3 by 2. So we're also going to have to multiply everything else by 2 as well. So this 2 times 2, negative 1 times 2. So 6x minus 4y equals negative 2. And I'm going to go ahead and write that underneath this one so that we can combine them a little bit more easy. So this is what we have now. We have this black and the purple equations, and in order to eliminate that 6x on both of them, we simply need to subtract one of the equations. So we'll add that 4y and we'll add that 2 there. So this now eliminates, and we're left with 4y minus 2z equals 6. And this is a key equation. We're going to want to keep track of that. So star it, and then we'll use it in conjunction with this third equation right here because it has the variables y and z in it, and then we can use the process of elimination or substitution or graphing even in order to find both of those values or one of them at a time. So looking up here to the right, I have both of those equations, the start equation and then our third equation here from the original set. And we can use these two now in order to eliminate. I'm going to use the process of elimination to eliminate y. So in other words, I need the coefficient of y to be the same. So I'll multiply this 1y by 4 to get 4y, but I've got to do it in all the other terms as well. So that would give us a 4y minus 12z equals 8. And now that the coefficients are the same, we just need to take the opposite of one of them. So I'll just use the bottom one and make that a negative 4, but I need to change the signs of all the rest of them as well. And that will eliminate the y's. Then I just add and subtract vertically here. So negative 2z plus 12z, that would give us a 10z equals 6 minus 8 is a negative 2. Then finally, to solve for z, we just need to divide both sides by 10, and we find then that z equals negative 1/5 if we simplified it. So there's our first answer. Alright, now that we have that z value, let's go ahead and figure out which value we want to find next. So looking at these three equations, you can look here as well, we can see that when we have the value of z, the value of y in this equation is very easy to find. So I am going to use that equation up here, but instead of z, I'm going to replace that z with the value of z that we found, which was a negative 1/5 right here. So when I multiply these two, I would get a positive 3/5, and the rest of that equation stays the same. Finally, To solve for y, I just need to subtract 3/5 from both sides, which would give us a 0 pair right there. And we would find that y, having common denominators, right, that would give us 10/5 minus 3/5. Some of you guys have calculators that would do this for you, but that would just give us 7/5, which is our y value. And now that we have the y value, in order to find x, if we look at these two equations, I don't know that one's easier or harder than the other, but now that we have the z and y, we just get to choose which one we want to substitute. So since we just found the y and it's kind of new, let's go ahead and use that top equation. So I've rewritten that equation here, but instead of y, of course, we would have a 7/5 there. And the rest of the equation doesn't change, but we can multiply those together, which would give us minus a 14/5 right there. This is equal to -1. In order to isolate the x, we'll add 14/5 to both sides. And that would give us a 3x equals, the -1 would be 5/5 there. So that would give us now a 9/5. Then in order to solve for x, we just need to divide both sides by 3. So x in this case, we don't usually divide with fractions. You would reciprocate the 3 and then multiply. So that would give us 9/15, which would then simplify by dividing both of these by 3. And then we would have 3/5 for our x. So there we have it. If we wanted to write the answer to this, we could write it as a coordinate triple. So the x is 3/5, the y is 7/5, and the z is a -1/5. But I highly recommend you guys, especially since you've done so much work in order to find these, just to check your answer, alright? Especially if your teacher is letting you use calculators, because plugging those values into that equation using a calculator is very easy. And we're going to do that right now too. So let's go ahead and check our answer. Checking your work, especially on tests, is critical because it helps you find out if your answer is correct or not. And some of you guys stress out a lot about tests, and it's just a really good way for you to walk away knowing that your answer is correct. Okay, now if something was wrong with the answers that we found here, when we check, which we're going to do, we would have to go all the way back to the beginning probably, or work from the back to where we started and figure out where we made a mistake. Sometimes it's with minus, sometimes it's with a plus. Something small like that, sometimes it's that we divided by the wrong thing. You just never know, okay? So let's go ahead and check. Alright, so in this first equation we need a true statement. So 3 times 3/5 would be 9/5. And then multiplying these two, it'd still be minus. 2 times 7/5 would be 14/5. And this needs to equal -1. Well, since we have common denominators already, if we combine these, would have a -5/5, which does equal -1. So this one checks off, our first one. Alright, and this is the second equation. 6x minus 2z equals 4. So when we multiply these two, we get 18/5. And then we would have what would end up being a positive 2/5, and this of course needs to equal 4, right? So since we have common denominators, when we combine these we get 20/5 equals 4, and 20 divided by 5 actually is 4, so this one, it checks off as well. So between these first two equations, the first two check off. Finally we'll check the third. Alright, so there we go. I've replaced the y minus 3z, the y and z I've replaced. And the 7/5 isn't going to change, but -3 times -1/5 would be a positive 3/5. And of course, this all needs to equal 2. So moving our work over here. 7/5 plus 3/5 would be 10/5. That needs to equal 2. 10 divided by 5 is actually 2. So this one checks off as well, you guys. So it looks like the answer that we had in the beginning, that we had found, actually is going to be this 3/5, 7/5, and -1/5. Alright, so we checked that off. There's one last thing I kind of want to go over with you guys, because notice in the beginning we found this equation here, right? There's another way you can do it. If you look at that third equation, y minus 3z equals 2, you could solve for y just by manipulating the equation, and that would allow you to use the method of substitution to find the x value using the first equation. So what I mean by that is you could add 3z to both sides, and then right away you would know that y equals 2 plus 3z, which then you would replace that y in this equation, which would then give you an equation with x's and z's only, and then you could use the method of elimination using these two equations. If that doesn't make any sense, that's okay. We've already done it using the method we have. But if it does make sense and it's easier for you, I recommend you using that because it's good for you. Alright, thanks for watching the video. If you liked it, please let me know. Just give me a like on the video, comment, and please subscribe to my channel. It really helped me out. Alright, thanks you guys. Good luck.